Okay, let's give you guys some more practice. So find the limit of this as x heads towards infinity. So press pause and have a go. Okay, so to do this, first check as x tends towards infinity. This is going to be very big. This whole thing here is going to be very big. So natural log looks like this. It's heading towards positive infinity. So this thing here, as x tends towards infinity, this thing here is going to head towards infinity. And then if you look at this thing here will also head towards infinity. So here you've got infinity over infinity. So you can apply L'Hopital's rule. So differentiator. So applying L'Hopital's rule, differentiate this. That will then give you this. Differentiate this. That will then give you this. So now tidy this up. So visualize as this divided by 4. And then the 4 gets multiplied to the bottom. So it gives you this. So now this here is a constant. So take it out. That will then give you this. And then now if you put this into here, this is going to go to infinity. Put it into here. This whole thing here is going to go to infinity. Here you can apply L'Hopital's rule again. So differentiate this. That will then give you this. Differentiate this. That will then give you this. And then it's really exactly the same thing divided by exactly the same thing. So this is a bit like x over x as x tends to infinity. This thing here is like 2 over 2, 3 over 3. It is heading towards 1. So this thing here, exactly the same. It is heading towards 1. So this whole thing here will be 1. So your limit is this. But back here, you should use your gut instinct when you get to this stage here. So when you get to this stage here, use your gut instinct here. As x tends towards infinity, as x gets very big, this thing here is going to be very big, and then this thing here, this thing here is going to be very big, and then you're gonna add a tiny amount onto there. So this 2 here is really insignificant. So it really boils down to, in a way, x over x, because it really boils down to something very big divided by something very big at the same rate. So your gut instinct just tell you that this is very similar to something of the form something over something as x tends to infinity. It's in the form of x over x in a way, which will lead you to 1. So the limit of this is really 1. You should use your gut instinct when you get to this stage here. But if not, then use L'Hopital's rule, differentiator, and then differentiate this, and so on. The limit here is 3 over 4 as x tends to infinity. Okay, so this bit here is 3 over 4. Okay, next one. So find the limit of this as x tends to 1. So a and b are constants. Okay, so press pause and have a go. Okay, so to do this, as x tends to 1, this thing here is going to be 1, and then you take away 1. So here you're going to have 0 over 0. So you can apply L'Hopital's rule. So differentiate this, that will then give you this. Differentiate this, that will then give you this. So now this is a constant, so you can take it out, and then you've got this thing. Take away this thing, then tidy this up. This will give you this, and then this thing here, this whole block here, as x tends to 1, it is actually 1 because a and b are constants. Because if you look at this, as x tends to 1, this thing here is going to be 1. Let's just say this here it turns out to be the number. Let's say 3. 1 to the power 3 is 1 times 1 times 1, which is still 1. Let's say a take away b happens to be 4. So you've got 1 to the power 4. That's 1 times 1 times 1 times 1. That's 4. Let's just say a minus b happens to be 3 over 4. then you can break this up as 1. So this is 1. So you can imagine this as being like this. You can break this up as 1 to the power of 3, and then hang on, and then this. So this thing here is going to be 1. So when you take the fourth root, it will still be 1, and so on. Well, this whole thing here, as x tends to 1, will be 1. So this whole thing here will be 1. So the limit is a over b. Okay.